Question 6 and the mark scheme can be broken into 6 tasks. They are: accepts and responds to user input, validation with range check using relational operators greater than and equal to 1000 and less than or equal to 9999. Use of library subprogram len to work with any number of users in the list. Use of Boolean to stop loop when found or passed over. Use of two-dimensional in user list. Display of appropriate messages. Question 6 has a levels-based mark scheme. This covers solution design, good programming practices, and functionality. This is the original question from the GCSE 2020 Computer Science Specimen Assessment material. This question is framed in the context of input, process, and output. The exact requirements of the program are set out, but there is no guidance for how the requirements are to be implemented. In this question, students are given the opportunity to demonstrate design, good programming practice, and functionality in their solution. This is the file that the students are given during the exam. When students are given a data structure or partially completed code, they should use what is provided and not change it. In summary, the marks for response A were awarded as follows. Lines 39 to 49. 1 mark for accepting and responding to user input. Line 46. 1 mark for range check with relational operators. Line 56 and 58. 1 mark for use of function len to catch end of list, which allows for any length list. Line 58. 1 mark for using a Boolean operator to terminate the loop. Lines 59, 61, 63, and 67. 1 mark for indexing a two-dimensional data structure. Lines 63, 66, and 74. 1 mark for appropriate messages. And now we move on to the levels marks. 3 marks for design, because the program is fully decomposed and the logic is clear and appropriate. 3 marks for practice, because the layout of the code is clear. The variables have meaningful names and are initialized at the start of the program. Comments are insightful and aid readability. 3 marks for functionality, because the program is fully functional and robust. It meets requirements, producing informative outputs. The total mark is therefore 15. You or your students may wish to annotate onto this example those accredited points, and then look at how they might improve them to score a higher mark. For response B, marks were awarded as follows. Lines 32 to 37, 1 mark for accepting and responding to user input. Line 36, no marks for range check since the incorrect relational operators have been used. Line 42, 1 mark for use of the function len to catch end of list, which allows for any length list. The evidence for a Boolean flag to stop the loop when the search item is found or position for entry is passed over was not found in this solution. Line 44, 1 mark for indexing a two-dimensional data structure. Lines 45 and 55, 1 mark for appropriate messages. Moving on to the levels marks. 2 marks for design due to clear decomposition, clear and mostly appropriate logic, and use of variables. Choice of constructs, if and while, are also considered. 2 marks for practice due to clear layout, meaningful identifiers, providing some useful comments, and use of white space to aid readability. Initialization of variables occurs in an ad hoc fashion as they are introduced rather than altogether at the start of the program. 2 marks for functionality, because the code is only partly functional. The terminating condition used in the while statement is incorrect, causing the last item in the list to be overlooked. This means that in some circumstances, a valid input will produce an incorrect output. The program is therefore only partially robust. The condition used in the if statement on line 54 causes it to crash if the variable not val has not been previously assigned a value. This only happens if the statement on line 40 is executed. The total mark awarded is 10. For response C, the marks were awarded as follows. Lines 35 and 36, 1 mark for accepting and responding to user input. Line 41, 1 mark for range check with relational operators, which is equivalent in function to that required by the mark scheme. Line 45, 1 mark for use of the function len to catch end of list, which allows for any length list. The evidence for using a Boolean flag to stop the loop when position for entry is passed over was not found. Line 50, no marks for indexing a two-dimensional data structure, as although an attempt at some type of index appears, it is inaccurate for this structure. Lines 40 and 42, 1 mark for appropriate messages that follow correctly from the context of their location in the code. And now for the levels marks. 2 marks for design due to clear decomposition, some aspects of the response being required in the solution, some accurate use of variables, some choice of constructs being required in the solution. 2 marks for practice due to clear layout, meaningful identifiers, providing comments, and use of white space to show logic. 1 mark for functionality, because parts of the code are required in the solution and are functional, particularly up to line 49, where indexing becomes inaccurate. Note for the identifiers in practice, the use of the letter I was not considered appropriate. The total marks are 9. There is no requirement to validate name, so no marks awarded for that. In this example, the student has turned around the logic for validation so that it is different to the mark scheme. However, it is equivalent and therefore credited. Lastly, for response D, marks were awarded as follows. Lines 30 and 31, 1 mark for accepting and responding to input. Lines 32 and 34, no marks for validation of range. Although there is an attempt to validate input, the incorrect relational operator is chosen. The evidence for use of a function, len, is not found. This function is required when processing all records or finding out when the end of a list is found. There are no marks for the Boolean flag to stop processing. This also affects efficiency of the solution. There are no marks for 2-dimensional indexing. There is no attempt to use the data structure given. Finally, lines 33 and 35, 1 mark for appropriate output messages, even though not all contexts are handled. And for levels marks, there is 1 mark for design because validation is attempted, lines 32, 34. And some of the constructs used, while and if, are required in the solution. There are no marks for practices as no comments are provided and layout is not addressed. There are no marks for functionality as the code does not provide even a partial solution to anticipated inputs. The total mark is 3. Sometimes students will not have time or not know how to complete all the requirements. You may well see comments indicating what would have been done, repeated instructions, or advice to go somewhere else in the program. These cannot be awarded marks. However, these types of comments might help inform judgment for the levels-based part of the mark scheme. Again, review the mark explanation document for additional explanation, including how this candidate could have improved their response. You might want to consider how different this response was to the first example we saw. And again, how you might improve this response to achieve higher marks. An open-ended scenario is suitable for this type of question. However, the exam time constraints need to be considered. Students should be able to complete the task in 25 minutes. Therefore, presenting a totally blank page may not always be appropriate. In the question text itself, provide just enough information that students need to accomplish the task. This particular question is presented giving the requirements for input, process, and output. State each requirement using a verb. If possible, state each requirement from a positive perspective, avoiding negation. This question uses a levels-based mark scheme. This provides an opportunity for students to be creative and approach the problem from their own perspective. When allocating items to the points-based part of the mark scheme, only those items that are predictable across many different solutions should be identified. You can use this flowchart as a step-by-step to both support the creation of this question type and also the decision-making behind it, creating an accessible and challenging question for your students to complete. This final video concludes this series of analysis and learning using the sample assessment materials. We hope you have found them useful, and we look forward to sharing more resources with you in the future to support your teaching of GCSE computer science.